can be added. Tapos nung interpretation ng vector, so we've provided it here. So orange vector U plus green vector V. And then if you draw V after U, then so you get 0, 0 to this new point. That's the vector U plus V. And vector, the location doesn't matter. What's relevant for a vector are the length and the direction. There is an atypical vector, the zero vector, the length is 0, and therefore it doesn't show us any direction. But all other vectors would be able to show us a direction. So we talked about the interpretation of the scalar multiple, subtraction of vectors. Oh, also, ito din pala, no, other interpretation of the vector sum, A and B. So if you complete the parallelogram out of A and B, so that diagonal in blue is also the vector A plus B drawn from the same starting point as vectors A and B. The dot product is a particular way of finding the product of two vectors. There's another product, the cross product, which we're gonna look into. Okay. Some nice properties of the dot product. Well, there's one. A dot A is no different from the square of the length of the vector A. And furthermore, if theta is the angle between two vectors u and v, whereby angle, we are referring to that angle theta, which is between 0 degrees and 180 degrees, then the angle can be retrieved from this formula involving the dot product. A dot b equals length of A times length of B multiplied by the cosine of theta. Okay. So some consequence of that, let me write it down here, March 2023. So we start, yay, okay, vector A, and then vector B, and that's the angle theta between them. So A dot B equals the length of A, and then length of B, and then cosine of theta. And then, so the dot product can be positive, it can be 0, it can be a negative number, because cosine theta, well, theta is between 0 degrees and 180 degrees. So one of the things that we get out of this is the following. If you take the absolute value of A dot B, so that's going to be equal to the absolute value of the thing on the right. Okay, but the length of A and the length of B, these are already positive constants. And so the only thing left is the absolute value of cosine theta, which is less than or equal to 1. So therefore, this absolute value of the dot product is less or equal to the length of vector A multiplied by the length of vector B. Okay, so that's sort of an upper bound on the dot product of two vectors. Another very important consequence is the following theorem. Okay, the vectors. Okay. The non-zero vectors A and B are orthogonal. Orthogonal is one of those fancy words in mathematics, which is actually synonymous with another term. So I'll mention what that term is. Well, actually, orthogonal means perpendicular.
Wala po siyang masakit, may sore throat kasi si Joshua eh. Kaya
okay. Oh, Joshua, but okay ka lang. Are you in good spirits? Are you in okay spirits? Okay, so okay. Ha ha ha. Okay. Joshua, we're gonna make fun of you, and I know you wouldn't be able to say anything. Ha 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 ha. Ha 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 ha. All right. Okay. Okay. So the non-zero vectors A and B are orthogonal or perpendicular if and only if their dot product is equal to 0. If you look at the main statement here, perpendicularity is equivalent to theta being 90 degrees. But then cosine of 90 degrees is going to be 0. And so if that were the case, then A dot B on the left side would be equal to 0 on the right side. And then vice versa, if the dot product is equal to 0, so if that's 0, then that would mean the right side would also be 0. But because the vectors A and B are non-zero, so that means the length of A is positive, the length of B is positive. So the only thing that can be 0 here is cosine theta. And the equation cosine theta equal to 0, this would have infinitely many solutions, like 90 degrees, 270 degrees. But because of the fact that we are restricting the angle theta between our two vectors to only be from the first and second quadrants, then the only way that this is going to happen, cosine equals 0, is when theta is equal to 90 degrees. So that's actually a nice criterion to have for the perpendicularity of two vectors. Once you have the components, you simply need to take the cross product, and right there and then you would be able to conclude perpendicularity. So in fact, we have the following cases involving the dot product. So, all right, one extreme is this. A and B are pointing in opposite directions. And then another situation is that the angle between them is obtuse. So that's theta. And when A and B are pointing in opposite directions, theta is equal to 180 degrees. And then here is where the angle between them is 90 degrees. And we know that in this case, A dot B is 0. Okay. The angle is acute, theta obtuse. Here, theta is acute, vector A and vector B. And then other extreme case is that A and B are pointing in the same direction. But if they're pointing in the same direction, the angle theta between them is 0 degrees. Now, if theta is acute, then what that would imply is that cosine theta is going to be positive. But then the lengths of A and B are positive. So this would mean in the acute case, the dot product is positive. What would happen to the dot product if the angle is obtuse? The cosine of theta is going to be, ano yan, Joshua? All right, so ganon or ganon? All right. Eh, ba't nagsasalita? Dapat, ano, preserve your voice, kid. Preserve your voice. All right. Negative. So A dot B is negative. Okay, and then we have the two other extremes. Cosine theta equal to 180 degrees, so cosine theta is going to be -1. All right, so in that case, what's going to happen is that A dot B will be, well, negative, the product of the lengths of the two vectors. And then if theta is 0 degrees, cosine theta is equal to +1 exactly. So A dot B equals simply the product of the lengths of A and B. So, well, positive pa rin, and here negative pa rin. But in the extreme cases, where the angle theta is 180 degrees or 0 degrees, then in this inequality star, equality is achieved. Okay, so with equality, if and only if theta is 0 degrees or 180 degrees, or in other words, vectors A and B are parallel to each other, and they could be pointing in the same direction or in opposite directions. Okay. Was it you who mentioned that in some of your physics lessons fairly recently, you used the dot product to find the work done? Thumbs up or thumbs down? All right. Okay. But was that something that all right, but was that something that was explained why the dot product gives you the work, or so was that explained, yes or no? It was just given. And then half sideways, the thumb goes sideways. All right. So okay. So I'll provide an explanation, and the argument actually uses this theorem that we proved. This one. Okay, that the dot product equals the product of the lengths multiplied by cosine theta. Oh, but before we go there, hold on, I forgot. A standard that some references follow is that the zero vector is considered orthogonal to any vector. Uh, So it's just a matter of standard, not really in the sense that you could actually see a 90-degree angle there, because how could you? We can't even draw the zero vector as a ray with a positive length. But owing to the fact that when you take the dot product of the zero vector with any other vector, the result is going to be zero. So parang ano, sinasama na siya doon. Hold on, wait. Uh, okay, application. Okay. So, okay, here are 3 points, P and then Q and um, then here is a vector P R. Okay, so, so here's an explanation of the setup. Force PR is applied to an object moving it through the displacement vector PQ. Find the work done. So compute the amount of work. Now, in typical high school classes, high school physics, or at least from my experience from high school physics, work is or is equal to force times displacement. Okay. But the setting was, at least from what I remember from my high school classes, the force exerted and the displacement are in the same direction. So, for example, the typical high school problem would be talking about an object at point P is moved to point Q with a force of 7 newtons. So if the object is moved from P to Q through the displacement, so that means the force being applied is a push from P to Q, and therefore the force is parallel, and not just parallel; it's in the same direction as the displacement. Okay, but in a more general setting, the force applied doesn't have to be parallel to the displacement, and that's shown in the figure. The force PR might be inclined at an angle theta from the displacement vector. And when I was thinking about this situation, of how that could happen, one thing that I was thinking of was, let's say PQ is level ground, and then you have an object, and then you're holding a string. So yeah, how string. This looks like an alien. All right, but all right. But hey, not so bad, right? It looks more like a person rather than a dog, right? Okay. So, but here's the thing: you're pulling you're pulling the object, and so the force. This is the direction of the force, and yet the displacement is that way. So there's an angle theta, which is non-zero between the force and the displacement. You know what? I like this drawing, so I am not going to erase this. Instead, I'm just going to move it. Haha, ano yan? SETI. Okay. Okay. Another situation that I'm able to think of is you have uh, water current, water current, and so it's anything in the water is being pushed that way. But let's say you have a tube here, which is inclined. Okay, so water is flowing in that direction, and then so there's an object there, which is and imagine the tube is a screen mesh, so that the water is able to flow through the mesh, and so as the water moves through the water current, this object is going to be pushed eventually along the tube along a displacement represented by the displacement vector, and the force and the displacement vector are not parallel to each other. All right, so that's already two such situations. Okay, but then to be able to apply high school physics, what we actually need to do here is, let me draw it again. Okay, P, Q, and let's say this is the force PR. Okay. What we need to do is okay, we're still gonna and also in high school, well at least in regular high school classes, syempre wala namang depiction of vectors in terms of components having of there being two components. So walang ganung representation ng vector in, let's say, grade 10 physics. Okay, parang ang ginagawa, minumultiply lang talaga the lengths, the magnitudes. And so what we need to consider, what we need to use is actually the component of PR along PQ. So if you drop the perpendicular and let's say it meets PQ at S, then what we need is PS. Okay, so so vector PS would be the effective force that we're going to be using because that's the component of the force in the direction of PQ. So the high school physics computation would actually go like this. The work done is equal to the length of the component of the force along the displacement multiplied by the distance traveled. Now the distance traveled is that would be the length of vector PQ. And the first factor, the length of the component of the force along the displacement, well, the component is PS, and so it's the length of PS. Okay. However, if theta is the angle between the force PR and the displacement vector PQ, then we can actually use trigonometry and observe that the cosine of theta is equal to the length of vector PS divided by the length of vector PR. Diba? All right. Typical Sokotowa. Therefore, allowing us to rewrite the length of PS as the length of PR multiplied by cosine theta. And so now the work done is equal to the following. PR, length of PR, multiplied by the length of PQ, multiplied by the cosine of the angle theta between them. And then if we go back to, hey, that thing in green, look at the right side. The product of the lengths of the two vectors multiplied by the cosine of the angle between them is merely the dot product of those two vectors. But hey, isn't this expression for work that we ended up with precisely that? Two vectors, we took their lengths and multiplied by the cosine of the angle between them. In other words, this turns out to be PR dot PQ. And so in other words, work is force dot displacement. So that's why. From high school, it was, well, in the limited setting, force times displacement, but in the more general setting, work is force dot displacement. All right. Actually, this is not even yet the most general situation, eh? Okay, kasi here we are assuming that the force being applied is the same vector PR all throughout. Pero kasi pwedeng halimbawa ng let's say andito si P, Q, where when the object is here, then the vector being applied, let's say, has this direction and length. But then when the object has already been moved there, what if the vector is different, and then let's say it's shorter, but the direction's like that. So pwedeng pa iba-iba ng vector eh. Pwedeng pa iba-iba. So parang when the object is at a specific spot, iba na nung force. So syempre, this thing is not going to be applicable anymore. And in that case, deeper calculus would be needed, specifically integrals. May integration na gagamitin. And even then, this setup is not even yet the most general. Kasi what if the path that the object travels from P to Q is not a segment, but a curve? All right. So let's say as it moves like that, the force vector is like that, and then when it's here, the force vector is like that, and then when here, the force vector, pag ganyan. All right. Okay.
Sir, habang nakikinig po siya, kain lang po siya habang nakikinig.
Sige, okay lang. Ako naman ay nagkakape rin.
Apa.
Okay, so pareho tayo. Okay. Kasi ano, Sir J, baka kayo naman mag-sandwich, baka kayo nung mainggit sa amin. All right. So anyway, Joshua, this is just to show that the world out there is much more complex. Usually, mga napag-aaral sa high school, parang we just go further and further in generalizing the situation. So, although at least na-explain ko na, no? Because you said in your physics class, this was just given that work is force dot displacement, but what this argument does is it presents an argument. So that the force times displacement, but really, the everything was in the same direction, but here this is much more general. Force dot displacement. So work is a scalar because it's a dot product, and a dot product is a scalar. In fact, it might seem anomalous, but di ba, the dot product can be negative, and that's gonna happen when theta is obtuse, di ba? So halimbawa, even though ganito, no, so ito ng P, Q, and then the force being applied is like that, theta. But then, even if the force being applied is like that, so nangyari ng object nag-go that way. I can't think of a particular situation yet right now, but then in that case, parang nangyayari nung pull mo parang pabaligtad di ba? So, but following this, that would mean the work done is negative scalar. All right. So that's very much possible. There are, alam ko, other situations where the dot product is also used, but this is what I remember the most. Or work is force dot displacement. So there is another operation involving vectors, which is the cross product. All right. Pero parang ang haba-haba na ng exposition go. We will talk about the cross product, but I think it's high time to go through some exercises. We start with the simpler ones of how we can use vectors to prove some geometric properties. Now, these geometric properties, we have already proved them, or at least we can prove them synthetically without using vectors, but it's still instructive, okay, to see how we can use vectors. Okay, so some geometric properties can be proved using vectors. Okay, hanap ako ng ano ba nung all right, ito. So one example, okay, show that the midpoints of the four sides of a quadrilateral form a parallelogram. Okay, so for example, we have A, and then B, and then C, and then D. Then when you take the midpoints, so they would be the following. And we want to show that they actually form a parallelogram. And my illustration seems to support that we do have a parallelogram. It is possible to prove this without using vectors. Here's an easy argument. Ganito pa lang, oh. Ito. Okay. So if you look at diagonal AC, we see that, let's give labels to the midpoints, A, B, C, D, and then this is E, F, GH. Okay. So if you look at EF, kasi in the context of triangle A, B, C, okay, EF is a midline because it connects the midpoints of AB and BC. So therefore, EF is half of AC and parallel to AC. But then by the same reasoning, it's not just EF, but also GH. GH is parallel to the diagonal AC and half of AC. So ibig sabihin, those two orange segments with the check marks, they are actually parallel and congruent. So yun na, we have a parallelogram. And I think without using vectors, this particular proof is easy. So I think actually it might be the easiest proof there. So a vector proof would be unnecessary, but I just want to provide an illustration. Okay, so how are we going to do that? Ganito. Given a collection of points on the plane, let's say A, B, and then C. Okay, let's observe the following standard. Let O be the origin. Okay, and so from O, you have these vectors OA, OB, and OC. Now, the vector OA, okay, corresponds to the point A. Okay, so parang mangyayari, assuming that the vectors we're gonna draw are all drawn from the starting from the origin, then that means to distinguish all these different vectors, the only thing that we have to consider is what the terminal point is. So you have point A in that case. So therefore, to ease the notation, let's say when you have to write down OA plus OB, okay, we can simplify the notation by writing that as A plus B. All right, so when you write down A plus B and you wonder, hey, what does that mean? A and B are points, then that would mean, well, we are adding the vectors OA and OB. I mean, after all, diba, kapag if A has components P, Q, and B has components RS, diba? OA plus OB, mangyayari din naman on the left side, that would be adding P and R, and also Q and S. So on the right side, when you think of A as the point with coordinates PQ and B as the point with coordinates RS, then ultimately you're kind of doing the same thing, adding P and R, and then you're adding Q and S. All right, so sometimes we might just write down, we might decide not to write down O anymore. So instead of OA, we might just write down A plus B. And so therefore, when we see something like B minus A, this would be vector OB minus vector OA. But then, what is OB minus OA? Remember our interpretation for subtracting two vectors. So if you look at, actually in my illustration, I don't need vector C. Can you see where vector OB minus OA is? It's what needs to be added to OA to get vector OB. So ito yon. This would be this orange vector. This is going to be OB minus OA. Okay. So when we see B minus A, that's vector OB minus OA. So ibig sabihin, as soon as we see, for example, C, where C and D are different points, then that's merely vector OC minus vector OD. Okay, where A is whatever the origin is. Okay, but actually, the choice of origin is entirely up to us. Okay, so halimbawa, dito sa illustration natin, let A be the origin. Okay, so if we let A be the origin, then that means nung AB, okay, would just be B, kung ganon. If A is the origin. Okay. Let A be the origin. Okay. So, kasi ganito, we want to, of course, be able to describe the midpoints. So, E is halfway from A to B. So, from that, so we know that AE, vector AE, is half of AB. So, using our standard for simplifying the notation, so we can write E is half of B. Okay. How about H? Also, H is half of D. Okay. Now, what about F? All right. Well, kasi we want to show that the four sides of a quadrilateral form a parallelogram. So one of the things that we could do is look at EF and HG. Specifically, let's compare vectors EF and HG. So we want to show they have the same length and that they are parallel. And so in other words, we want to show that these two vectors are actually the same. And if we're going to be able to do that, that would be enough to show that EFGH is a parallelogram, to show that vectors EF and HG are the same vector. Okay, you might be wondering, wait, don't we also need to check EH and FG? Do we need to check them or not anymore? Hindi na. All right. Okay. So, kasi I don't know if I presented this argument before. If you have two segments which are parallel and congruent, then they actually form up then the endpoints actually form a parallelogram. Yeah? Or okay, so you're okay with that argument. Okay, great. So but then EF, so oh, also hold on, sorry. Let me complete the thing that I was writing down here. OB minus OA is in fact vector AB. And so OC minus OD, this is gonna be bale C minus D, no? So it's from D to C. So DC. So nung sinusubtract is where you're starting from. So nung EF, this would be F minus E. And HG, this would be G minus H. So we want to show that F minus E equals G minus H. So here we are writing things, representations for E and H. So that takes care of this E and this H. So what we need to do is come up with representations for F and G. Okay, so how are we gonna do that? Well, nung F is okay, F is AB plus BF. Okay, F is AF, of course. All right, F is vector AF. So that's and then AF is from the figure AB plus BF. Okay, but what characterizes so and then AB vector AB. So using our notation, that's B na lang. And then BF on the other hand is half of BC, half of BC. And then, in fact, we can write this further as follows: B plus half of BC on the other hand is C minus B. Right, C minus B. So we can do a little bit of algebra here and come up with a half of C plus half of B. So half of B plus C. Actually, that's something that's useful. All right, pwede nating diretsuhin no for future reference that if you have a segment MN and P is their midpoint, then we could go right ahead and conclude and write down the fact that P is half of M plus N. So vector OP is half of vector OM plus vector ON, because that's pretty much what we arrived at here. So F is half of B plus C, and so likewise, G is, similarly, G is half of, because it's the midpoint of C and D, half of C plus D. All right, so ngayon, now let's compare EF and HG. Para mangyayari, algebraic na lang siya. Okay, EF is F minus E, where F is half of B plus C, and then E above is half of B. And this is half of C. And then HG is G minus H, where G is half of C plus D, and H is half of D, which is half of C, which means HG and EF are the same. Therefore, EFGH is a parallelogram. Okay. In fact, the arguments here apply even if A, B, C, D do not form a convex quadrilateral. Let's say you just have 4 points. So kunwari, A, and then andito nung B, and then andito nung, hold on, maybe I need a little bit of space. Okay, let's say here is where we have A, and then B is here, and then C is there, and then andito si D. Okay, so parang no, A, B, C, D. All right, and then let's follow the same notation. A to B, so A to B, that's E, and then B to C, the midpoint is F. C to D, the midpoint is G, and then D to A, the midpoint is H. So if you follow the order, E, F, G, H, where would that be? E, F, G, H. If it looks a little bit distorted, well, that's on me. Okay, but that's still supposed to be a parallelogram, and therefore a convex quadrilateral out of EFGH.
Intersecting polygon. Intersecting polygon po.
Yes. Actually, intersecting polygon, even pwede din halimbawa non-intersecting polygon. Let's say ito nung typical A, B, and then C, and then let's say D is here. Okay. A to B, so the midpoint is E. B to C, the midpoint is F. C to D, the midpoint is G. D to A, the midpoint is H. So E, F, G, H. All right. Because after all, if you look at the argument here, parang ano it doesn't really depend on the relative positions of A, B, C, and D. Nung arguments natin. So therefore, even in these atypical pathological anomalous situations, EFGH is still going to be a parallelogram. Yay! Okay. Ano pa nung isa kong nice, no? All right. So, okay. Ito, since we're talking about, ito, okay. Next example. If the diagonals of a parallelogram have the same length, then it is a rectangle. Of course, visually, if you draw a parallelogram, which is not a rectangle, it is clear that one diagonal is going to be strictly longer than the other. A, B, C, D. In this case, we see that AC is longer than BD. Let's use vectors. Well, of course, this can be proved without using vectors, but let's see how we can use vectors. And again, so that instead of, we can decide that A is the origin, okay? Let A be the origin. What makes a parallelogram a rectangle? I guess we'd have to go by what is a rectangle. One way to define it is that it's a parallelogram having one of its perpendicular. Okay? So, ibig sabihin, meron tayong 90 degrees. It would suffice to show that the angle at A is going to be 90 degrees. Kasi if it's a parallelogram, that would mean, kung ang angle at A is 90 degrees, edi 90 degrees din yun at C. And then the angle at B is supplementary to A, which is 90. So that would mean this is 90 also at B. So tuloy-tuloy na sila, even D. So showing that the angle at A is 90 degrees is enough. But then, how do we show that? How can we prove that? Well, we can look at vectors AB and AD. So to show that you have a 90-degree angle there, so dot product. So we have to show that AB dot AC is equal to 0. Or using if A is the origin, then we just simply need to show that B dot C is equal to 0. Okay, but our starting point is that the lengths are the same. Okay, so that's the given. Okay, so BD, so that's our starting point. BD, so let's say vector BD is the same as the length of vector AC. Okay, pero how can we produce a dot product out of this equation? Let's recall what property involves dot products and lengths. What is V dot V? V dot V is, and the square of the length of the vector V. And hey, we have lengths here. So if you square, then that means we can write dot products all throughout. So BD squared equals AC squared. So in other words, BD dot BD is equal to AC dot AC. Okay, and then BD, well, A is the origin, no? So BD is, this is D minus B. So you have D minus B dot D minus B. And then likewise, what's going to happen here is, paano ngayon ng AC? Well, this is going to be AC is C minus A, but A is the origin, so this is just going to be Well, C. Or actually, hold on. If we're using the tip, kahit hindi na pala natin ilagay ng arrowhead. Kasi we already know what the starting point is, which is the origin. In this case, it's A. So here, C dot C. Okay. Then what do we have here? C dot C. We have now when we were talking about the dot product, I think I wrote down some properties. So that would be from Feb 22. All right. A property like this simply implies that when we carry out dot multiplication, we can proceed as if we were multiplying algebraic expressions. I mean, if we're comfortable with writing x multiplied by 2y plus 3z is equal to 2xy plus 3xz, we're simply applying the distributive property. And because that applies as well to dot products, then we can be as comfortable with distributing vectors in a dot product as if we were working with polynomials. So here we get likewise d dot d minus b dot d. So d dot d, then b dot d minus d dot b, and then minus b dot minus b, so plus b dot b. That's equal to c dot c. All right. Now, what do we have now? We have d dot d, and then d dot d. That's likewise. Well, d kasi is, so if you look at d dot d, so that would be the square of the length of d. But then, of course, what we really mean is the vector AD. Kasi AD is, all right. So either if I put the arrowhead, but it's going to be no different naman eh. The length of segment AD and the length of vector AD, they're the same. So here we have AD squared minus 2 times B dot D plus AB squared equals AC squared. Okay. What I observe here is kasi we haven't really used yet the fact that this is a parallelogram. We have to use that this is a parallelogram. And in particular, so that means AD must be the same as the vector BC. And AB is the same as the vector DC. Kailangan magamit natin sila. Okay. So let me rewrite this. 2b dot d equals ad squared plus ab squared minus ac squared. Okay. In particular, I'm looking at AC kasi, oh, hold on, I see. Ito, from the figure, they see that vector AC is the same as AB plus BC. But then because you have a parallelogram, BC is the same as AD, yung nasa base. Or in other words, B plus D. So actually, AC is C. So C equals B plus D. So let me insert that here. Kasi nung sa right side, C dot C. C is B plus D dot B plus D. So gawin rin natin nung distribution. Kasi you're gonna get B dot B plus B dot D plus D dot B plus D dot B. Kita mo na kung ano nung mga nice na mangyayari dito. Ito, copyhin ko lang ito nasa taas. Okay? So, ang daming magka-cancel. D dot D here, B dot B here, and so what you're gonna get is, and then B dot D and D dot B are the same, so minus 2 B dot D on the right side, twice B dot D, and then it's easy to conclude that B dot D must be 0, scalar 0. But then that means vector AB and vector AD have dot product equal to 0, which means at angle A, we do have a 90-degree angle. Thus, angle BAD is 90 degrees. So ABCD is a rectangle. All right. Okay. Isa pang example. Show that an angle inscribed in a semicircle is 90 degrees. Okay, something we've already encountered before. Okay, but this time let's use vectors. So we have a semicircle, and let's say the endpoints of the diameter are A and B. And then for an inscribed angle, we choose an arbitrary point C there on the semicircle. And we know from previous geometry lessons that angle ACB is 90 degrees. Let's show using vectors that is so, that's the case. Here though, a natural choice of origin would be the midpoint of the diameter. Alam nga namang A pa nung gagawin nating origin. I think it's more natural. Also because we have to exploit the fact that we are in a semicircle. In particular, that means OA, OB, and also OC, they have all the same length, the radius. Okay, that's precisely what's going to characterize the fact that we are working in a semicircle. Okay, so and furthermore, OA and OB are two vectors in opposite directions having the same length. So that means OA and OB are negatives of each other as vectors. Again, because they're parallel, they have the same length, and in opposite directions. Okay, so let R be the length of A, length of B, length of, well, of course you mean OA, OB, OC. Okay, and then what else? Note that B equals negative A. So we want a 90-degree angle there. So in other words, we should show that vector CA dot CB is equal to 0. All right, because that's what perpendicularity is. So we have now reduced that to showing that a dot product is equal to 0, CA dot CB. So what we got to do is represent CA and CB. CA is A minus C. CB is B minus C. Okay, so let's take the dot product. CA dot CB. This is A minus C dot B minus C. Oh wait, let me point out that take O to be the origin. Now let's do algebra here. A dot B minus A dot C minus C dot B. So sulat na lang natin is B dot C plus C dot C. A and B are negatives of each other. So A dot negative A, and here minus A dot C. And then itong negative B, well, that's A. So you have plus A dot C plus C dot C. And we can see what's going to happen to the middle two terms. That's going to be the scalar 0. And then we have minus A dot A plus C dot C. But do you see now what's going to happen? Negative. A dot A. That's the square of OA. And then C dot C, that's the square of vector OC. So in general, this is what's going to happen. But because we are in a circle, the length of OA is R, the length of OC is R, so negative R squared plus R squared. Joshua, what is negative R squared plus R squared? I need your input here, kid. What is negative R squared plus R squared?
The natural logarithm of the Higginbound constant.
Ano ba? Akala ko ba kailangan ipahinga mo ng boses mo? Dami-dami sinasabi.
Patatas po,
So,
patatas.
okay, ayan. So 0. So therefore, CA dot CB 0. Therefore, angle ACB equals 90 degrees, right? Yay. Okay, so fairly useful nung the characterization of perpendicularity in terms of the dot product. So parang we're actually showing that something is 90 degrees without even measuring angles explicitly. Yeah, well, just as long as, everything works out fine. So, okay, ano pa bang mga examples na ito? If the diagonals of a parallelogram equal in length, then you have a rectangle. So done. We proved some concurrency statements. Like for example, the medians of a triangle are concurrent. Okay. Let's see if we can use vectors. Example, show that the medians of a triangle are concurrent. And then the point of concurrency is called the centroid, and we know that it actually divides each median in the ratio 1:2. So in a so the shorter segment of that median is 1/3 of the entire median's length. But these were things that we proved before. So let's see how we can use vectors. How would that help us? Because I remember, well, let's say this is B and C, and then A, and then if B is the midpoint, we argued that D is half of B plus C. Diba? Meron tayong ganong argument already. And then so A, D, tapos actually this can be concluded no matter what the origin is. So if kunwari, we mean for the origin to be O, so that D means vector OD, this would be true. But then if the origin we take is point A, so that D means AD and B means AB, this equation would still be true. Okay, because D being equal to half of B plus C depends only on the fact that D is the midpoint of BC, not really on what the origin is. But for convenience, sometimes we choose one of the vertices or one of the points already given as the origin. Okay, so ito, I'm thinking, sige, let's or how about let me use A as the origin. Okay, sure, sige. Baka mapadali. I haven't done this proof in a long while, so I hope that mag-work. Anyway, let's just help each other next. Okay, so A is here, and then this is B, and then this is C. A, B, C, and then as usual, we have this is D, and then this is E, and then this is F. All right. I-connect natin first are BE and CF. Okay, so the medians corresponding to B and C. Kasi nung A special to eh. Kasi A is the, we're gonna take it to be the origin. So ganito, gawin natin, let's denote this by G. Okay, so to show that the medians are concurrent, we have to show that A, G, D are collinear. How would we show that they are collinear? Well, we could consider the vectors AG and AD. Okay, if they are collinear, then that would mean vector AG is embedded in vector AD. And with G being in the interior, so basically what we got to do here is show that AG is parallel to AD. But then when are vectors parallel, that would be when they are multiples of each other. Okay, so what we're going to do is show that AG and AD are multiples of each other. In fact, we can even guess what the multiple is. What we're going to do is show that AG is 2/3 of AD. Diba? Kasi that much we know, or at least, I mean, that's what we expect from what a centroid is supposed to be. So we're going to show that G is 2/3 of D because we're going to take A to be the origin. Okay, take A to be the origin, and then refer to the figure on the left. All right. Well, first, let's characterize the segment. Well, E and F are midpoints. So AF is half of AB, but then the origin is A, so we know that F equals half of B, E is half of C, and then D is the midpoint of B and C, so this is half of B plus C. Okay. So ng CF is F minus C, which is half of B minus C. BE is E minus B, where E is half of C. So we have 1/2 of C minus B. Ito medyo hindi ako prepared dito. Paano kaya ito gagawin? G is the intersection. Okay. Let BE and CF intersect at point G. So, ganito. Ang gusto kong gawin, you see how nung E and F, we can, well, kasi A is the origin. So, basically, that means triangle ABC is determined by B and C, and well, A, but we end up not writing A anymore because it's the origin. So naturally, we anticipate F, D, and E. We should be able to write them down in terms of B and C, and that's actually the case. And so, because once you have the triangle, the centroid is unique. So I'm thinking, hey, you know what? Wouldn't that mean that we should also be able to express G in terms of B and C? So that's what we're gonna do. Try to express G in terms of B and C. All right. So kasi, I mean, the entire triangle depends only on the locations of B and C. So everything else, somehow it should be possible, maybe complicated lang. The orthocenter, the circumcenter, the incenter, we should be able to express them in terms of B and C. Okay, but then let's figure out how exactly that's gonna appear. Or how that's gonna look like. Okay, G is the intersection of B. So when we say G, B, E, and C, F intersect at G, so this means G is on BE and on CF. Para lang standard, I'm starting these vectors from all right. Okay, G is on BE or EB and also on CF or FC. But well, that would mean if G is on BE, so that would mean BG is parallel to BE. All right. And in particular, BG is a multiple of BE. So we can write down BG is R times BE, where R is some mysterious constant. Actually, knowing what the centroid is, what should be the value of R? R should be 2/3, diba? BG should be 2/3. But right now we don't know that because we're not assuming things we already know about the centroid. But we do know BG is a multiple of BE. Let's denote that multiple by R. And then I anticipate that eventually we are going to be able to show that R is 2/3. And then it's the same with CG. So ganun din. Okay. Thus, okay, BG is equal to R times BE, and CG is equal to S times CF, where R and S are some numbers in the open interval 0, 1. Okay, tapos here's hoping mapapalabas natin ng values ng R and S, although I'm not sure how, pero sige, subukan natin. BG, this is G minus B, R, and then BE is half of C minus B. And then CG is G minus C equals S. And then this is CF is half of B minus C. And from both of these, G is B plus R times half of C minus B. This is also C plus S multiplied to half of B minus C. All right. Let's look at the latter two expressions. So let's simplify the middle one. We have B times 1 minus R. So 1 minus R B plus R over 2 of C equals, here on the other side, 1 minus S C plus S over 2 B. And we can move things around. 1 minus R minus S over 2 B equals 1 minus S minus R over 2 C. All right. So wait, here we have the following statement. B and C are multiples of each other. But then, hey, when two vectors are multiples of each other, doesn't that mean they're parallel? All right, what do you, I don't know, what? So, well, but of course, B and C are not parallel. But clearly, okay, AB and AC are not parallel. Okay, so the only way that this equation star could hold is if the coefficients are 0. All right, because if the coefficients are non-zero, then that would mean, halimbawa, even if even if ito lang nung 0, but then on the other side, well, 1 minus S minus R over 2, dapat 0 din siya. And C is different from A. C is different from A, so C is not the origin. So, all right. And so what that would then give us is a system of equations. 1 minus R minus S over 2 equals 0, and 1 minus S minus R over 2 is equal to 0. So we should be able to solve for R and S. Okay, okay, hala, dito tayo natigilan. R plus S over 2 equals 1. R over 2 plus S equals 1. When you add 3 halves, R plus S equals 2. So R plus S equals 4/3. When you subtract these two, we get the following. S over 2 equals 1/3. So S equals 2/3. And if S is 2/3, that means R is also 2/3 in order for the sum to be 4/3. All right, nice, no? All right, so, or ako lang nung natuwa. Okay, so that means R equals S equals 2/3. So therefore, G can now be written in the following way. B plus R, which is 2/3, half of C minus B. So what's going to happen is B will have coefficient 1 minus 2/3, which is 1/3. 1/3 B. And as for the coefficient of C, 2/3 times 1/2, that's going to be 1/3, which is nice, no? Kasi symmetric. So G is 1/3 of B plus C. G is 1/3 of B plus C. Okay, but what is AD? Okay, D is half of B plus C. Okay. Oh, all right, here we go. G is 1/3 of B plus C, and from above, D is half of B plus C. So that means G and D are multiples of each other. In fact, what we see here is that G is, ano siya, anong ratio siya? G is 1/3 divided by 1/2. G is 2. Oh, wait. Yeah, in terms of D, G is 2/3 D. All right. So actually, that's it. AG is 2/3 of AD, so that means AG is on segment AD, and so AGD are collinear, which means G is not just on those two orange medians already drawn, it is also on the median AD. And furthermore, we are able to retrieve the right ratios, the right relationships between how the centroid G partitions each median. All right, and that's using vectors. Okay. G is 2/3 D, therefore, okay, thus G is also on the median AD. This means the medians concur at point G. All right. So in general, if you have a triangle A, B, C, and then so if you connect the medians, so they're going to intersect at G. So it turns out that G in general is 1/3 of A plus B plus C. The reason why A doesn't appear here is because we have taken A to be the origin. But the statement G equals 1/3 of A plus B plus C is more general. Let's say if the origin was somewhere else, if the origin G was chosen to be a different point. All right. Okay, but hey, we've been talking about so tapos na tayo sa medians. How about ano i-take natin angle bisectors? Kaso nga lang, wow, how are we gonna do that ng angle bisectors? Or how about try mo muna, okay? Matagal na ako hindi nakakapagbigay sa ng ng task eh. So try mo, all right? Show using vectors that the angle bisectors of a triangle, okay, that the angle bisectors of a triangle are C or cute. Okay. Cute and concurrent. Pinakamahirap dyan alright, showing that they're cute. Seryoso ako dyan never tayo nagjo-joke, Joshua. Lagi tayong serious. Okay. But if to explore what you could use here is the fact that kasi A and then B and then C and then let's say this is the angle bisector. Ang hirap kasi to do this in terms of the angles eh. Okay, but let's say the AD is the angle bisector. Okay. Kasi what we do know is there's nung BD and CD. So just so it's clear that I'm referring to the lengths. So let me use those vertical bars. BD over CD, diba, this is equal to the length of AB over the length of AC. All right, so that's something that's going to come in handy. So if we use the usual symbols for the length, so small c, small b, and then small a. So this would be b over c. All right, we can, for point D, do the following. Maybe I'll try to do this in general, where A is not necessarily the origin. Okay. So, kasi, ito. I want to describe A, D, ito, AD. This is AB plus BD. All right, AB plus BD. So that would be the vector AD. And then nung vector BD, well, kasi but nung BD, you can think of that as C times K. And CD, B times some constant K. Hello?
B over C, C over B boy. Ito po yun, sir.
Thanks for correcting that. Otherwise, hahanapin natin siya ng error. So C over B, right? But anyway, so it's so from the figure, so that means CK plus BK equals A. So that means K is A over B plus C. So ibig sabihin, BD over, so actually BD, the length of BD over the length of BC, okay, BD is, ang length niya CK. Nung BC, ang length niya is A. But then this is C over A, then K is A over B plus C. So that means this is C over B plus C. So what I'm comparing are segments BD compared to BC. Shorter segment, shorter orange over longer orange is equal to C over B plus C. So ibig sabihin, I can write here, okay, AB. So this is A plus B, and then BD is C over B plus C multiplied by vector BC, which is B plus C. All right, so then we have the following: A plus, and then paano ngayon ng B, ang kasama ng B ay 1 plus C over B plus C, and then B. And then for C, it's C over B plus C multiplied by C, which is now equal to the following. Parang pangit kasi I would expect na symmetric siya kasi parang I would imagine that the coefficients of B and C should not be too different in appearance. So wait. BD is kasi if we're going to go further, dapat nung expression natin for AD is the best possible expression. I was hoping for symmetry. Kasi kung titignan mo nung AD, parang hindi naman nag-appear nung B and C dyan eh. So I was expecting here on the right side, the way that B and C appear along with their coefficients, parang dapat balanced. But why does it appear like the coefficient of B has so much more things happening there? So that's why I feel that halimbawa kasi pwede natin gawin ganito, no? AD, we could have expressed it as AC plus CD naman. Okay. And AC, that's A plus C. And then nung CD, oh wait, hold on. Sorry. I think I made a mistake. I think my mistake is here. Okay, so ganito. BD is the coefficient C over B plus C of BC, right? And this is really C minus B. Yan ang tama, di ba? So this is wrong. This should be C minus B. So let's do this again. So here's hoping that we're gonna arrive at a better looking answer, A. And then B has coefficient 1 minus C over B plus C over B plus C multiplied by C. A plus, and then the difference, diba, that's going to become, oops, that's not just going to be B over B plus C, B plus C over B plus C, C. Better looking na, diba? Looks better now. So that's AB. Okay, so this is AD. So now, without going through the same level of detail, you should not be able to write down an expression for, let's say, dun naman sa kabila from C, let's say the angle bisector is, let's say, those two are the same and this is F. So now you should be able to write something down for CF. Okay, CF should be C plus, and then something multiplied to A and B. Tapos, these should be fractions with denominators A plus B and respective numerators small a and small b. All right. And then just like before, let I be the intersection. So we should be able to express I in terms of the in terms of A, B, and C and the length. So try to explore. All right. And then continue. Okay, but I feel like yun may mga nasimulan na tayo dito. Okay. So angle bisectors, and then if you could try it for the perpendicular, at least for the orthocenters. Try mo lang. I don't know if see if you can come up with something regarding that. All right. So let's try this. Okay. In a convex quadrilateral, a midline is a segment connecting the midpoints of opposite sides. So you have two pairs of opposite sides, so that means there are only two midlines. If the sum of the lengths of the midlines equals the semi-perimeter. So what's a semi-perimeter? We encounter this usually in Here's formula, but hey, it's merely the half of the perimeter. And so you can also apply that definition to polygons in general. Just take the perimeter and then divide it by 2. So if the sum of the lengths of the midlines equals the semi-perimeter, show that the quadrilateral it starts with the letter P.
Mm.
Show that the quadrilateral is poly. Parallelogram is a parallelogram. All right. So let's consider one such convex quadrilateral. And then to simplify the notation, let's take one of the vertices, A as the origin. Let A be the origin. So for the midlines, this is E, F, G, H. So EG and FH are the two midlines. Okay. Let E, F, G, and H be the midpoints of the sides as shown. All right. So we're talking about the lengths of the midlines. So that would mean this is our working condition. The length of EG plus the length of FH equals the semi-perimeter. So that would be half of the length of AB, but then that would be so I'm writing these down as segments, but of course you can also take them as vectors. So AB, but hey, A is the origin, so vector AB is just B. So length of B plus BC vector's length plus vector CD's length plus vector AD, so that's just D. All right. So what we could do is we can work things out. So nung left side, kasi E, F, G, H, these are all determined by A, B, C, and D. And then A is the origin. So B, C, and D are the only points which are free to range anywhere. So we're gonna try to write everything in terms of B, C, and D. So if you take vector E, G, so of course this is G minus E. And then G is the midpoint of C and D. So we have half of C plus D. And then E is the midpoint of A and B. So half of A plus B, but A is the origin, so this is just half of B. So that's EG. And then FH on the other hand. So this is H minus F. H is half of D. F is half of, well, F is the midpoint of B and C, so half of B plus C. So, okay, EG is the length of, so the length of EG is half of the length of C plus D minus B. And FH is half the length of D minus quantity B plus C. So D minus B minus C. And then on the other side, half of length of B. And then as for BC, well, that's C minus B. So half of C minus B. And then half of CD, so half of D minus C. And then half of the length of D. There's lots of 1/2s here. So you can cancel out all the 1/2s here. So this is what we end up getting. Half of C plus D minus B plus half of D minus B plus C equals length of B, length of C minus B plus length of D minus C plus length of D. And then if you're thinking of the fact that the length of a vector x squared is x dot x. Kaso nga lang, there are so many vector lengths here. And if you're thinking of squaring the left and right side, that's just going to be terrible because on the right side, you would be squaring a polynomial having 4 terms. So, gugulo sobra. So here's hoping that the resolution can be observed by, I don't know, there's something here about the fact that, it's not just any weird combination. Look at it, C plus D minus B. So I don't know if that's something that you can see there on the right side. Well, C plus D minus B, part of it is C minus B, which we see here, plus D. Oh, wait, hold on. Sorry. I copied something incorrect. This is B minus C. If it helps, let me rewrite things as follows. Okay. C plus D minus B equals C minus B plus D here, length of C minus B plus length of D. Next, the length of D minus B plus C. Let me write it down as length of B plus C minus D. On the right side, we have not written down yet. So we're done with this and this. So we still have length of B and then length of D minus C. Let me write it down as C minus D. Okay. Look at the terms underlined in yellow. Those are 3 vector lengths, the lengths of 3 vectors. What is true about those? If you're given, so if you look at C minus B plus D, Hey, that's actually the sum of the two vectors on the right side, underlined in yellow. Are you typing something or no? Okay, ganito. Let's say we have vectors u, okay, vectors, okay, ayun, all right. Lengths of u, v, and u plus v. In general, what can be said about these three vector lengths? The length of the sum is less or equal to
Triangle inequality.
triangle inequality. Were we able to cover this? We were able to talk about this, were we? Triangle inequality for lengths of vectors. All right. So kasi if you look at the length of C minus B plus D is less or equal to the length of C minus B plus the length of vector D. And the length of vector B plus C minus D is less or equal to the length of B plus the length of C minus D. So itong left-hand side and right-hand side, in general, the left-hand side must be less or equal to the right-hand side. But from equation star, equality occurs. So that must mean that in our two successive applications of the triangle inequality, equality actually holds. So now we go back to, but hey, in the triangle inequality, when does equality hold? Where equality holds if and only if u and v are
Orthogonal.
horizontal.
Orthogonal daw po.
Orthogonal, tignan natin nung discussion natin ng triangle inequality para ma-review tayo. So is that, yeah, we started vectors from previous meeting natin. Ito, triangle inequality here. Okay. With equality, if and only if A and B have the same direction. So ito yun, no? All right. If they have the same direction. In fact, if they're orthogonal, mangyayari, nung sum vector A plus B, it will be the hypotenuse. So, in fact, Pythagorean theorem, nung mag-hold in that case, C squared equals the sum of the squares of the other two. So in this case, if equality holds, that means U and V point in the same direction. Okay, since equality holds in a star, then if you look at the vector pair C minus B and D, then this must mean C minus B and D point in the same direction. But then C minus B and D point in the same direction. Okay, so this is 1. Also, from 2, B and C minus D. B and C minus D also point in the same direction. But from I, tingnan natin ng figure, C minus B is BC. And D, which is AD. So they point in the same direction. So that means BC and AD are parallel. Okay. Point in the same direction. So AD and BC are parallel. However, wala tayong conclusion that they have the same length. So they're just parallel. So that's why we also need number 2. B is AB and C minus D is the vector DC. These point in the same direction. So AB is parallel to DC. So now we have concluded AD parallel to BC, opposite sides. Also, the other pair of opposite sides, AB and CD, are also parallel. Therefore, ayun na, ABCD is a parallelogram. Yay! All right. Okay, so parallelogram. So actually hindi man lang tayo gumamit dito ng cross ng dot product. It's just ito. Before let me type one other thing for you to try. All right. Oh, I know, like you're so happy. You're so, oh, thank God. That's what you're doing, right? Okay. So that's what you're doing. Okay. Try and then add this too.
Wala na mo yung secondary color na ano.
Next time. All right. Given A, B, C, D are points in space. They don't even have to be coplanar. Show that AC squared plus BD squared plus AD squared plus BC squared is greater than or equal to AB squared plus CD squared. So just so it's clear, when we write down AC, what we mean here is the length of segment AC, or which is equivalently the length of vector AC. Okay, so here you can think of these as lengths of vectors being squared and added as shown there. All right, so for now, I think this is a good place to how about one more?
No.
Well, after all, kasi isa pa.
Parang isa pa sabi niyo, sir, parang nag-light up yung mukha ni Joshua eh.
Oh, di ba? Hindi ko nakikita. Parang tinatago niyo nung pag-line up. But anyway, as always, try to do what you could. Try to do what you could. So, all right, let me write down the following. Okay. Let O be the circumcenter of triangle ABC as usual. Okay. Okay. Let D be the midpoint of AB and E the centroid of triangle ACD. Recall that we already have a nice formula in terms of vectors for the centroid of a triangle. Prove that line CD is perpendicular to line OE if and only if AB equals AC. And recall that we have a nice way of characterizing perpendicularity in terms of the dot product. All right. So I think the elements are for trying out these problems are available based on our discussion. All right. So see you about Sir Jay and Joshua.
Thank you,
Bye.
sir.
Have a
Thank
good
you po.
evening. Adios.
Thank you po.
Okay. Where's the map?